Okay, this is the second part about the topic of mutual exclusiveness, mutually exclusive events. And it has two parts, 4 and 5, continuing from problems 1 to 3 in part 1. And I will just remind you quickly of two facts that A, if A and B, or let's write it like this. Maybe it will make it much easier for you. Probability of A or B is equal to, there are two things. Either the A and B are mutually exclusive, or they are not. Let's even do it with another color. Or they are not mutually exclusive. And let me even remind you, mutually exclusive means that A and B are disjoint or don't have any intersection. The other one, not mutually exclusive, it means that A and B do have an intersection. So there is something between A and B. They're in common, this part here. And this part, the orange part, is what we call A and B. Okay? And so the rule says that if you already know that they are mutually exclusive, the probability of A or B is the probability of A plus the probability of B. Very simple rule. If they are not mutually exclusive, then it will be almost the same. It's the probability of A plus probability of B, but you have to subtract probability of A and B because you will be counting it twice. If you look at the intersection that I drew here in orange, when you count it, you will be counting it with A and you will be counting it with B. So it will be counted two times. That's why we subtract it, so that we count it only once, as we should. But in a situation like when they are disjoint already like this, there is no intersection. So this here, A intersection B, is empty, and so the probability of A and B is 0 if they are mutually exclusive. Just remember this, and then you'll find that this question is very simple to answer. So the first part is we are given the probability of A, the probability of B, and the probability of A and B. Notice immediately, probability of A and B is not 0, which means that A and B cannot be mutually exclusive, so they are not mutually exclusive. And if they are not mutually exclusive, you know that not mutually exclusive, then the probability of A or B is this here. Probability of A plus probability of B minus the probability of A and B. So since you concluded already here that they are not mutually exclusive, you can say probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. All of these things are given to you. Probability of A is 0.27, probability of B is 0.34, minus the probability of A and B is given 0.13. And if you do this on your calculator, you should get 0.48 or 48%. So this is the probability of A or B. Okay? And immediately it was clear. This question is very clear, finding the probability of A or B, and you are given the three things that you need in order to find. But remember, once we saw that there is an intersection between A and B, because the probability of it exists, it's not just 0, then we know that they are not mutually exclusive, and therefore we know that we must use this rule that then we used, and we got the answer that the probability of A or B is 0.48. Let's go to the last part of this question. In this last part, they are giving us that the probability of A is 0.21, probability of B is 0.18, and probability of A or B is 0.38. And then the first question, are A and B mutually exclusive events? So let's answer it first before we do B. So if they're asking you, are they mutually exclusive, then if you want to remember, if they are mutually exclusive, then the probability of A or B must be the same as the probability of A plus the probability of B. So let's check here. Let's see, what is the probability of A or B? This is given to us here. Probability of A or B is 0.38. Now, what is the probability of A plus the probability of B? If you add the two probabilities, you'll get 0.21 plus 0.18, and this would give you 0.39. Unfortunately, these two numbers that we got are not equal. These two are not equal. So you can say, therefore, probability of A or B is not the same as the probability of A plus the probability of B. And from this, immediately you can conclude that A and B are not mutually exclusive. They are not mutually exclusive. Because if they were mutually exclusive, then the probability of A or B would be the same as probability of A plus probability of B. Let's go to the second part of this question, which is find the probability of A and B. Let's just highlight what we've done, just so that you don't get confused. I'm going to put a color around this part. Just this was the solution to part A, and now for part B we'll do it in black. Okay, so in part B we know that A and B are not mutually exclusive. So remember, from part A we know they are not mutually exclusive. So you can say, because they are not mutually exclusive, therefore probability of A or B is the same as probability of A plus probability of B minus probability of A and B. And notice that which of them are given? This one is given, the probability of A or B, it's given as 0.38. Probability of A is 0.21. Probability of B is also given, 0.18, and this is the one that we need to find. It's not given, but this is very simple. Just use simple algebra. You can say, therefore, probability of A and B, just take probability of A and B, it has a negative side, take it to the other side, the negative will go away, and then take this one to this side and it will become negative. So you can just do this. Probability of A and B is equal to the probability of A plus the probability of B minus the probability of A or B. And so this will be the numbers that we have, 0.21 plus 0.18 minus 0.38. And if you compute this, you will get, the first two will give you 0.39 minus 0.38 which is 0.01. So this is the probability of A and B. Of course, you know, if you don't want to write all of this and then find it at the end, you can just, from here, you know the rule, so just add these two numbers, because you have to add them, and then put them on this side and multiply by a negative sign to get probability of A and B. It's just like an equation that linear equation that you just take things to other sides just to find the number that's missing. You just need to find the question mark here. Find it in any way you like. But at the end, what matters is that we found that the probability of A and B is equal to 0.01, which is 1%. So this means that the probability of A or B uses the full formula. You remember that at the beginning I told you if they are mutually exclusive, you use this. But why do you use this only? It's because the probability of A and B is 0. So imagine that you are subtracting probability of A and B always. It's like the full rule. But if it's already 0, it's like doing nothing. You don't need to do it. So that's why it's not included in the formula when the two are mutually exclusive. But when they are not mutually exclusive, don't forget that you have to subtract the probability of A and B. And this will end this question.